Hey guys, welcome back. Some time ago I made a video in which I salvaged some 18650 cells from old laptop batteries, and I was a bit unlucky as half of the batteries actually had 0 voltage, and at that time I did not have the knowledge I now have, and I tried to just recharge them, but that is not going to work. However, you can actually use a multimeter to see if you can try to recharge them or if the internal battery protection got triggered. And this internal battery protection is called a CID, or current interrupt device. And that is what today's video is about. I'll show you the theory on how it works, how the CID acts and what it does, and we will go ahead and try to manually reset the CID. We'll go into all the details in a moment. So let me just start by showing you what a CID is. So the CID, or current interrupt device, is located on the positive side of a 18650 battery, and as you can see in here we have some holes, and these holes, they are vent holes. They are necessary for the CID to work properly. So the CID, essentially we have this top part, something like this. Then I'll indicate these vent holes as they're with space in between, and we have the top part, vent holes. So this is the positive top layer. Okay, this is what is visible. Underneath here we do have, on the side we have oh yeah, by the way, this is just cut down like this into a cell. You have to obviously think about it as being round. So then we have a layer of a PTC resistive material. That is very important. We will go into that in a moment. Then we have the next layer, looks something like this. That is the how could you call that? Essentially this is the top part of the CID. Yeah, let's call it the top disk of the CID. And then we have an insulative material sitting in here. So we have an insulator or isolator, doesn't matter. This electrically isolates the top disk from the bottom disk. And the bottom disk is then set like this. Alright, and in normal state we do have electrical contact in here, over here. Then around this middle pin we do have, I'll indicate it like this, around this center pin we do have a weak spot in the top disk. This can actually be blown off to actually vent the inside. Then we do also have some vent holes over here to vent the inner cell, as you have to imagine like this, that we do have the outer housing of the cell, something like this. So this is completely compressed. It's this top part. Let me show it here. This top part which completely presses together all of these layers. And then we go into the cell inside. Obviously this part over here is connected to positive of the inner cell structure. Yeah, so basically that's how the CID is constructed. Now let's talk first about the PTC material. I've read people saying or claiming that if the CID get triggered, the PTC material does no longer work, which is completely not true. You see, the PTC material is a resistive material that has nothing to do with the CID getting triggered. So PTC resistive material is essentially we have a resistance that relies on temperature or changes with temperature. So we have a graph over here, we have a resistance over here and a temperature over here. We're not dealing with any values right now, but we have essentially resistive minimum, then 2 times R minimum, and essentially the resistor curve looks something like this. And as you can see, at first, if the temperature goes down, this could be, the low point could be like at 25 degrees Celsius, for example. And then after that point, the resistance goes up. And this PTC material is in place to somewhat delay the time until the CID gets triggered. And this is only in fault state that this has an impact. Now, this is not quite right, as that also has an impact all the time. It's a PTC resistor material. As soon as the temperature goes up, so does the resistance. Therefore, we have a lower current that can flow through. But this is not to limit the current. This is just to delay the time until the CID gets triggered. And the way the CID gets triggered is in 2 states. If we take a look, we have these this bottom disk and the top disk with this center contactor. We have weak spots over here and here. And the CID can be triggered in 2 ways. It can either be triggered, we have the bottom layer, we have the top layer, and then suddenly this pin somewhat disconnects. It vents the cell, and we physically disconnect. We have no longer any connection here. There's no connection between the top pin and the lower, or the top disk and lower disk through this pin, and we vent the cell. And what gets vented is the electrolyte inside. All of the 18650 cells, or rather all lithium-ion technology batteries, have essentially 3 layers of material plus the electrolyte. We have an anode, we have a cathode, and we do have a physical separator in between. But this physical separator is somewhat like a paper-ish material, somewhat like a coffee filter material. Essentially, this material allows the electrolyte to be in between and make physical contact to both anode and cathode, letting ions pass through but stopping electrical connection. So in a state in which the cell is in a massive fault state, these weak spots break open, the pin somewhat lifts up or maybe even shoot out. We vent the holes, and what gets vented here obviously needs to pass through here as well. Therefore, we have these holes all around. So these are the venting holes for massive fault states. But the other way it could work, or rather fail or disconnect, is we have the lower pin, we have the upper pin, and it somewhat like lifts the pin a bit up. Yeah, so basically these are the 2 ways the cell can fail. And here's the important part. The electrolyte, if the cell fails in a way that you lose electrolyte, a few things can happen. The cell can no longer be charged to maximum voltage. The cell does not longer hold a maximum capacitance due to loss of voltage, and the cell could also lose charge over time. So if the cell does not go up to, let's say, over 4 volt DC, and it does not hold this charge for at least 48 hours, that's at least in my experience, then the cell has vented so much electrolyte that it is no longer functional. However, losing electrolyte means 2 things. You are no longer going to maximum charge, therefore not having maximum capacitance, but it could also mean that you are constantly discharging. So this is what I would definitely recommend. If you try this, the cell should hold 4 volt DC at least over 48 hours, but you should always charge them to maximum 4.2 volt and then let them discharge. And if they hold 4 volt DC or above for 48 hours, they will for ever, essentially. Well, they do discharge, but very, very slowly. Alright, so this is the theory on how the CID works. And The CID reset essentially means that you, in a fault state, try to push this pin back down to make contact. Now you can't do this in both fault states, but again, cells that vented electrolyte are more likely to not function properly anymore. And resetting the CID in this state also means you have to have perfect seal if this middle pin goes back down. Otherwise, as soon as the cell hits some temperature, it would just vent. All cells, as far as I'm aware of, do have in non-fault state a higher inner pressure than normal ambient pressure, essentially. So this means that we have to have a good seal, otherwise we are losing electrolyte. And resetting the CID also has some issues. If you try to reset the CID, the most common thing people do is they have a cell, use a small screwdriver, and they go in with a screwdriver in here. Where's my screwdriver? There it is. They try to pry this in through one of the holes and try to press the central pin back down, and that's a bad thing, and this I will show you in a moment. Alright, so I've got this cell over here, which I already showed you, and this is one of my test subjects. And if I try to focus, alright, you can see that this is a cell that I tried to reset the CID with a screwdriver. And if you take a look inside of here, you will see that we do have some dents in the CID that clearly come from my screwdriver. And because I use a screwdriver, I actually, let me just zoom in a bit more, damaged the CID and this weak spot all around here, and I actually opened up the cell slightly, as well as you can see that I have quite a few scoring marks from getting inside with a screwdriver and trying to pry this down. So this is not a method that I would recommend. Now the second try was this over here, which is also quite dangerous. This idea I got actually from YouTube, from someone I don't remember. I saw this before, I don't remember the channel or something, which was drilling into the top layer, very carefully drilling in and trying to essentially press the middle pin down with essentially I used a steel, no, I used a drill bit, right, I used a drill bit and tried to press it down, which also did not work. And this is quite dangerous, because if you slip and go too deep, you are drilling into a cell, and if there's any charge left, you are going to short positive, or your anode and cathode, positive and negative, and that could be really bad. So not recommended, didn't work for me. And my idea then was to just remove part of the top layer, and therefore I do have access to the CID as well as a visual confirmation on how it looks and if I'm doing any damage to it. Now the inner part, I don't know if you can see this, it doesn't look perfect. I still had a few problems. I again used the back side. By the way, when I did this, as well as this, I used the backside of a drill bit. Just a drill bit that was big enough for this middle part to be pressed back down without damaging the cell. And this worked perfectly. I mean, it doesn't look as good as I would like it to look. We do have some scoring, but the CID is back in place. We have no vent opening. The weak spots are perfectly intact, and the cell is perfectly fine. Tests okay. Has a capacitance from around 1350 milliamp hours. So definitely, I think it lost some capacitance, but I'm not 100% sure. These are unknown cells. Yeah, so this is what I think is at least the safest way to do this. However, if you do it, you have to be really careful. You see, these three parts over here are the legs that hold the top part in place, and before you reset the CID, you have to make sure that they are bent inwards away from the outer part, as the outer enclosure, if we take a look over here, this complete outer enclosure all the way down is negative. And only this black material over here separates your positive from the negative. And this is one of the isolating materials. So these pins, like this position, you have to bend them inwards so they don't make contact. I mean, it looks like it's far away, but still, if you do this, bend them inwards to make sure that everything's fine. So yeah, that is my idea. That works somewhat, as you do have visual confirmation if everything is all right. And here's the thing. When you hear about resetting a CID, people tend to say that if you reset the CID, it does no longer work, which is wrong, fundamentally wrong. You're literally only putting the central pin back into place. This does not mean that if an inner cell pressure rises, it does not go out again. I mean, honestly, I think it is easier for this cell to disconnect, or the CID to disconnect, than with a normal cell, as the material is now even more like weakened. So I don't think resetting a CID is a big issue. At least if you do it in a way that you do have confirmation, visual confirmation on how it looks, you're really careful and you do use something that does not have a sharp edge. Got rudely interrupted while filming. So, where was I? What was I talking about? I think I was talking about people say that the CID once reset, it does no longer work, which again, I think it's not true. If you take a look at this again, even, let me just focus, even if we have this situation over here where we still have contact, if you just press this down, or let's say, I think it looks a bit more like this. If you press this back down from something looking like this to something looking more, again, how it should, to make contact, that means that the whole material, all of these bands, are now weakened. They are no longer as strong as they were before the CID got triggered. So that means, in my opinion, that if the cell once again goes into fault, it's easier for the CID to trigger. And you have to also consider that bending out is just one of the safety features. The other safety features is to actually completely disconnect physically the pin and venting the cell. And you're not preventing the cell from doing that unless you're using a screwdriver, because that is a bit difficult. I'm not sure if you can see it. But if you take a look inside of here, doing it with a screwdriver, I'd say from how it looks, how the central pin looks, again, as also this outer ring outside of the weak spot got deformed, I'd say if you do it with a screwdriver, then yes, you can no longer rely on it being able to easily reset. However, if you do it the way I suggest, or rather, I'm not suggesting it, but I recommend, if you want to do that, if you want to try this, then open the positive up, so you have visual confirmation how it looks, and then use something rounded to press the central pin back in, and make sure that you do not bend anything, but you're just pressing down the central pin. And that is what I think has no impact on safety for the cell. Because here's another thing. The cell itself Because the CID get triggered does not mean that the cell was the problem. The CID gets triggered in all situations in which the inner cell pressure rises beyond a certain point. And when does inner cell pressure rise? Well, it always is a bit higher. That is what my research suggests. That's number one. And number two, it gets even higher the warmer the cell gets. And in all fault states, it's the cell temperature that lets the inner cell pressure rise, and it's the temperature that causes the CID to disconnect. But this temperature does not necessarily come from the cell. And even if the temperature comes from the cell, okay, so what I mean by that, first off, what I mean by that is, if you have a laptop battery, they're really tightly packed, and they're used all the time. And because there are so many cells, I mean, there are literally 6 cells, it looks something like this inside of a laptop battery. You have them cramped in with plastic material on the outside, and you're preventing the cells from safely dissipating temperature. Over time, there is a possibility that they could just disconnect the CID because there's constantly higher pressure on the CID itself than it is designed to handle, and therefore at some point one pops open and it's no longer usable, and then this next one until the battery is no longer used or usable, as it either doesn't work or has no longer its original capacity. But that is only one of the ways or one of the reasons that a CID does get triggered. The next reason is that we have another source of temperature from outside. Again, a laptop. Underneath the laptop, we have the laptop sitting on the battery, and on top of the batteries we have the main board, CPU, stuff like that, stuff that produces heat. And this heat, well, this heat energy goes into the cells. Can also cause the cell temperature to rise abnormally. And then we can also have an issue with the BMS. The BMS can be damaged. It can overcharge. That's another thing. If you charge 18650 cells with a current that is too high or a voltage that is too high, the cell heats up. As the cell again heats up, the electrolyte evaporizes. Evaporized electrolyte means higher pressure, and at some point the CID will then trigger, and again it can go into 2 fault states. So we do have a bunch of reasons that the CID can get triggered. That does not mean the cells are damaged. However, obviously there are cases in which the actual cell or the inner cell structure are damaged. So I'm not suggesting you reset the CID and just use them. If you decide to do that, to try it yourself, be careful. Once you once you reset the CID, observe cell temperature, charge the cell while observing temperature, and observe temperature afterwards. Let the cell not go, let's say, don't let it go over 40 degrees Celsius. While charging a used cell that is otherwise totally fine, the highest temperatures I've reached were in the mid-30s. So 40 degrees, still fine, but beyond that, a cell that you reset the CID, be really careful and take some safety precautions, like a fireproof container, which you can drop it in if something goes wrong. But I'm not expecting that anything will happen even with a damaged cell, because you have to understand also, if the inner cell structure is damaged in a way that the CID got triggered due to high cell pressure, we're dealing with seriously like connecting the inner anode and cathode. Therefore, even if you reset the CID, it can no longer be charged. A cell that is completely healthy holds its charge of at least 4 volts or higher voltages for at least 48 hours. And if that's the case, I don't see a reason why you shouldn't use a cell even if you reset the CID. Let me just quickly show you how you can test if the CID got triggered or if there's another problem with the cell. That is use a multimeter, set it to resistance measurement, and if a cell is okay, like this test OK cell, you try to measure the resistance between positive and negative, you will get a very, very low value. At least this multimeter cannot display it, but there should be some. But if the CID get triggered and you try to measure resistance, it's overload. There is no continuity, nothing. You could also do continuity measurement, but it's resistance that matters. So if no resistance is there, it does not work, and the CID get triggered. And now let's go ahead and try to reset one cell's CID. Okay, now I've got a pair of snips, and I'm going to insert these two pointy tips into two of the holes and just cut this metal part. And oh yeah, by the way, if you did the measurement I showed you, you can be sure that the CID get triggered, and it's not a problem if you accidentally short out the positive here and the negative here, as there is no electrical connection between the actual inner positive and negative. But before you reset the CID, make sure that the metal leftovers underneath here do not touch the negative outside. That is just something that you have to make sure, but otherwise it is completely safe for me to do that. I'm now going to bend this up, and I'll just cut this apart. Alright. Now that looks quite good. Yep, we do have access, so we have visual access as well as physical access. And now I'm going to use a screwdriver to see the metal parts are facing up and not towards the negative, and they do. Everything's okay. Right, and if we take a look inside of here, you may be able to see it. The CID is slightly warped outwards, and we have to press it down. I don't have my stuff. What could I use? I've got an idea. I mean, it's still pointy, but it's rounded shape. It has a rounded shape. So maybe, did this work? I'm just pressing in the middle, not trying to damage anything, and I think it did. Now let's see if we measure voltage, and it did. We do have 2.9 volt DC. Perfect. So the reset did work, but I do not recommend you do what I just did. It's just because I want to finish the video. I was essentially pressing right into the middle and just prying it down slightly. But I would highly recommend you use something that is really round and has the same size as this middle part over here, so you make sure that you do not accidentally score the material and you don't bend it in a way that the CID is no longer able to be triggered. But as you can see right now, we do have voltage, or you cannot see because I forgot to zoom out. So if I now go ahead, measure voltage, we do have voltage, and it does not change, which is very good. This means that for one, there's no metal touching, there's no short, the cell does not get warm, it is not warm. That's perfectly fine. The only thing that I have to do is, if you take a look on the positive over here, if it focuses, the cutting edge now sticks out a bit, so I have to bend this back down. I'm just going to use the back side of my snips to get it flat. And now it is flat again, and it can be inserted into a battery charger, and in a moment we will see if it did work. Okay, so just to clarify one more time, if you do decide to make a CID reset, I highly recommend you read the temperature of the cell while charging. It is now charging. I have my cheap thermometer over here, 2 pieces of clear tape to hold the probe in place, and I'm going to observe the temperature, and if this hits 40 degrees Celsius, I'll be really paying close attention, and above that, if it just goes like 45, I will definitely stop it, because right now we do have an ambient temperature of 29 degrees Celsius, and I'm not comfortable for the cell to go more than 11-12 degrees above ambient. So that's how it will charge, and I'll come back to you guys once the cell is fully charged. Alright, the battery has now been charged, and I accidentally stopped charging it at 4.13 volt. The charging circuit that I do have, these chargers, they don't charge apparently batteries above 4.1 volts, so it's not fully charged. It has been sitting for 3 hours. Now let's see if everything's okay. And the voltage we have is 4.07 volt. Now this is very typical. Used cells, they rarely hold their maximum charge they got charged to, but this means that the cell is fully functional after a CID reset. Now I personally am going to do more testing, but this is not part of the video. But as you can see, it does work. There's no issue with it. If there was an issue, by now there would not be a voltage present after 3 hours. You see, I only had these, this one and these 5 batteries left from the originally 15 batteries. I've been doing a lot of tests to get to the point that I know for sure that this kind of manipulation of the CID does work. I was thinking about what you could use if you don't have, like, I have a metal, like roundish metal bar thingy that has a rounded end that I use. I remembered. I think the easiest way you can do the same thing is you use a drill bit that is small enough and just reverse insert it into a drill, then use some sandpaper and round the end. And then you can use this to pull down the CID and reset it manually, and therefore the battery works once again. Now let me just clarify, I'm not saying that you should do this, but this is a way that you can do it, and I think the safest way. And I try to explain to you that I think it is safe to manually reset the CID. It is not it's not useless after resetting. It still works, and I think it's even more likely that it gets triggered, and therefore it is safe. But do it on your own risk. And so I hope you liked this video, and if you did, please leave a like, comment down below, and other than that, thanks for watching, and see you next time. Bye.